This is a brand new tube train being built for the Piccadilly Line on London's Underground, and next year you should be able to ride on it. The new trains are going to transform the way it feels to travel on the tube. Air conditioning and trains you can walk all the way through for the very first time on the deep tube lines. So how have they done it, and what are these new trains going to be like? We've come to the Siemens train manufacturing plant in Goole in Yorkshire to find out and to get up close to them being built. 158 million trips are made on the Piccadilly Line every year, more than 10% of all tube journeys. It's the second longest line on the Underground at 44 miles, or 71 kilometres, and also has the second largest number of stations at 53, serving some of the most important locations on the tube network, like Heathrow Airport, Buckingham Palace, the Natural History Museum and Covent Garden. But it also has the second oldest trains on the Underground, the 1973 stock. In 2014, Transport for London told train builders that they wanted to order new deep tube trains. Not just any deep tube trains, though. Ones that would include things previously thought impossible on the deep tube. Air conditioning and walk-through carriages just like the S-stock on the subsurface Underground lines, Metropolitan, Circle, Hammersmith and City and District. Fast forward to June 2018, and Siemens Mobility won a £1.5 billion contract to build 94 of its Inspiro-designed trains. Around 80% of those trains are now taking shape at speed in Goole, with the rest being built in Vienna. And we spoke to Siemens Mobility's joint CEO and Managing Director for Rolling Stock and Customer Services, Sambit Banerjee, to find out what's going to be different and better about the new trains.
These trains will be air conditioned, so that will make passenger journeys better. It will also make passenger journeys more comfortable because the passengers can walk through the length of the train, and if some parts are more busy, they can find themselves in other parts where they're not so busy. Trains are far more lighter, which means that will cause less track damage, and the overall concept is a sustainable train for next 35 to 45 years that will run in the heart of London. So that was the major concept, and that's how we built up these trains. And then there are more comfortable seating, there are handrails so that when it's too crowded, passengers are not feeling uncomfortable to travel. But we think with the combination of an air-conditioned train and a train where passengers can walk through will be the game changer.
Now we get to see how the trains are actually being built, starting with how they arrive on site in the first place. Mark Speed is the General Manager at Siemens Mobility's Goole Rail Village.
This is one of the first operations when the car body is delivered to the factory. So the car body is delivered on a lorry, as you can see there, and then this piece of equipment is called a gantry crane, which lifts the car body off the lorry and lowers it onto these elephant's feet. And underneath it here we have what's called car body movers. So there's a mover under each one of these elephant's feet. And the next operation that these guys are currently finalising is that the car will be moving out and into the storage warehouse over there for its initial inspections. And what we've come into here is our main assembly hall. So we'll walk down to the far end in a few minutes, but the cars come in at that end and they progress through the build stage to the final operational station before they go to the chucking operations, which is where they fit the wheel set.
So how big is this building?
This building's approximately 10,000 square metres. Oh. And what we have on this side, we have the main production line, and on the other side we have the warehouse.
So how many cars have you got being worked on in here at the moment?
So in here there's about 10 stations, and each station has one car, and you'll see some of the cars have two stations, so potentially about 12 to 13 cars in here at the moment. And what we have here, this is the first operation. So the cars will come in through the roller shutter doors, either at the bottom there, and the cars are located on what we call elephant's feet. So these orange fabricated items are what the car sits on. And these first operations, what you see here is that all the underframe equipment is fitted. So you can see there's a HVAC unit, traction drive units are being fitted. So the car will come in, have those fitted along with a lot of the underframe pipework and electrical cabling as well.
Luke Graves is a second-year hire apprentice manufacturing engineer on site. So what do you do on these bodies then?
So on these car bodies we have a selection of earth cables, These ones that connect directly to our HVAC units, LV units. So these are fitted by T-bolts that just go on the bottom, and it's just to make sure it's all protective and there's a safety backup if there's any voltage leaks. Yes, we'll take care of that and make sure the voltage gets grounded straight away. So my job is I'll get them all ready, pre-set up, get them torqued off, and I'll line them up and get them all into their located places as per the work instruction.
So how long have you been doing this for?
I've been at the company for 2 years, so since production started, so about a year ago now. So yeah, these used to be really complicated, but now time's getting on.
You've been doing them a while.
Yeah, doing them a while, so it's getting a lot easier, and I can sort of click off now and someone will check my work afterwards. And
what made you come and work for Siemens?
the reputation, the big name really, that's what drew me in. It's not too far away, I'm only a 30-minute drive, and yeah, the big reputation, big opportunities, and engineering is something I really want to progress in, and I knew I could do that at a company as big as Siemens.
As Mark mentioned earlier, the car bodies are moved around on site by remote-controlled car body movers. Siemens has used these in many of its plants, and it's not hard to see why. Traditionally, cranes are used to move car bodies to different workstations on tracks, but this takes up a lot of space and reduces the flexibility you have to move car bodies from one area to another, especially if there are problems. Instead, these remote-controlled car body movers enable the car bodies to be shuffled from one workstation to the next much more easily. And they're pretty fun to watch as they do their multicoloured synchronised dance to get into position. Next, we're off to the trucking building and catch up with James Liddle, Assembly Supervisor.
When a car body comes in, we bring it all the way in, we raise it on jacks to a certain point, then we mount the section to figure out the base depth, then we lower it onto a corner loading machine, we figure out the torsion of the body, and after that we determine what shim plate will make it level so we can sit it onto a bogie. We then raise it up off of corner loaders, and then we start fitting mounting gear, so all the running gear, all the mounts for dampers and safety tie ropes and secondary springs. Then we lower it onto the wheel sets, and then after that we ship it out. So we've just walked into the commissioning building. So we've seen the assembly building where the cars are assembled. We've been to the trucking building where they have the wheel sets fitted. And when they're fully complete with the wheel sets, then come in to be commissioned. And the first activity that's undertaken is the single car static testing, which is over in this bay over here. And we're just about to go and meet the team responsible for that activity.
Mark Mitchell is a commissioning technician on site. So what happens in here then?
So we receive the car bodies from manufacturing, we will hook them up to our test equipment, we will make necessary electrical connections, we will simulate the train car being as part of a 9-car consist, so we can load the software and then we check and test all the components of the vehicle.
Once the cars are commissioned, they are assembled as 9-car trains. The formation of the train is different from the old Piccadilly Line trains. Graham Clark, the head of business development for Rolling Stock, explains.
It's a 9-car configuration formed of 3 different vehicle types.
And what are those 3 different types?
There's an end vehicle, a driving vehicle, which has a cab on it, and there are 2 types of intermediate vehicle, one which has bogies underneath it and one which is suspended, so it doesn't have any bogies underneath it. It's an arrangement we call bogie offset articulation.
That sounds very complicated. So how have you managed to suspend it without having... So there's nothing underneath it that's holding it onto the track?
It's suspended from the end via a rather ingenious coupling.
And so has that been done before on a tube train anywhere, or is this the first time that...
I'm not aware that that's been done on a tube train. There are similar arrangements of vehicles in Stockholm and Hamburg, but this is the first time I'm aware it's been done on a tube train quite in this form. It's quite common on light rail.
The new Piccadilly Line trains have been tested on the Siemens test track at Wildenrath in Germany and are now being tested in London. Siemens and Transport for London had hoped that we'd see the new trains in passenger service and be able to travel on them by the end of 2025. But that's now been pushed back to the second half of 2026, apparently because of the complexity of their introduction into service. Siemens then hopes that an order for more trains for the Bakerloo line will follow soon and keep the factory in Goole busy building trains for many years to come.